In this section, we're going to look at multiplying and dividing rational expressions. We've done this a little bit before when we were working with fractions and when we first introduced variables. When we multiply things with fractions, our general rule is that we multiply straight across the top and straight across the bottom. But if we had an opportunity to try to simplify or reduce along the way, we always wanted to take that. So for example, here in problem number 8, we notice that there's a 5 in both, that 5 will divide both into this 5 on the bottom and this 25 up here on the top. So 5 goes into 5 one time, and 5 goes into 25 5 times, and we're able to simplify and reduce our expression down a little bit. At this point, I've got y's on the bottom, but no other y's on the top, so that's as much canceling or reducing as I can do. And so I just multiply straight across the top and straight across the bottom to get to my final answer. On the top, I can do the 3 times the 5 to get 15. Then I have an x squared and an x to the third, which when I put those together end up with x to the fifth, because 2x times x from here and x times x times x from here gives me 5x's altogether. In the denominator, we'd reduce that bottom part number down to 1, and then we had y to the fifth. Remember, 1s are optional to write as coefficients, and so this is a great acceptable solution for my rational expression after I multiply those values together. When I'm dividing with rational expressions or fractions of any kind, remember the very first thing that you want to do is you want to switch that division problem into a multiplication problem, and we do that by multiplying by the reciprocal. So recall, to divide with fractions of any type, with variables or not, we always want to multiply by the reciprocal instead. So you need to make that change before you try to divide out any common factors you may have. So for example, here in problem 9, that 2a to the third b over 15 stays. The division changes to multiplication, and then we're going to find the reciprocal of that second fraction by flipping it over. Now I have this expression that I want to multiply. Again, you can multiply across the top and the bottom and simplify, but life's a lot easier if you can find any common factors to simplify along the way. In this example, I noticed that 5 will go into both 15 and 20, so I can use that to reduce down. 5 goes into 15 3 times, and 5 goes into 20 4 times. 2 on the top won't go into any of these 3's on the bottom, so that's it in terms of number parts. I do have both a's and b's in the numerator and the denominator, so I can reduce those down a little bit. This a on the bottom will cancel with one of the a's on the top and leave me with a squared on top. The b's, I have both a b on the top and the bottom, so when I divide those out, the b's are gone altogether from the problem. At this point, all we want to do now is multiply straight across the top and straight across the bottom. Along the top, we had a 4, and there was a 2 and an a squared, so that will give me 8a squared on the top. On the bottom, I had a 3 and a 3. Everything else was canceled out along the way. And so my final solution here is 8a squared over 9. So these concepts of looking for common factors to divide out, and if we have division, rewriting it as multiplication before we start, we're still going to continue to use those today. But as we look at multiplying and dividing with rational expressions, keep in mind our rational expressions may have pluses and minuses within them. So for example, when I look at problem 10 here, I see 3x minus 6 and x plus 5 and 6x minus 6. If you want to cancel or reduce out any common terms, you can only do it if they're next to a plus or a minus, if you cancel out the entire expression. So for example, I have a whole x plus 5 group here that's a factor. Right now we kind of want to think of it this way, right? Because each of these pieces in my multiplication separates these pieces out in this particular way. I do have an x plus 5 and an x plus 5 that I should be able to cancel and reduce out because we can cross the entire terms out with each other. However, with the 3x minus 6 and the 6x minus 6, it doesn't immediately look like there's anything I can do. Before you get too far, I really recommend checking everything to see if there's anything that you can factor so that you have your values in their simplest factored form. That way you may identify or recognize things that you are allowed to cancel and reduce before you continue in your problem. For example, the 3x minus 6 has a common factor of 3 that I could pull out. So I can write this as 3 times x minus 2, which is the same thing. On the bottom, I have that x plus 5 I really couldn't do anything with. Over here, I have the x plus 5 on top, which is as simplified as it can be. But on the bottom, I have 6 times x minus 6. There's a common factor of 6 there that I can pull out, and I would be left with x minus 1 behind in parentheses. At this point, now that everything is completely factored, I do want to take the time to cross out any common factors, divide them from the top and the bottom, so that I can have the simplest form possible when I'm finished. Oh, sorry about that. Here, the x plus 5s are going to cancel, so we have one on the top and one on the bottom. Those can go. In terms of this, I have an x minus 2 and an x minus 1, completely different expressions, can't do anything with that. But on the outside, I had a 3 and a 6, and I can't reduce those like I would normally. 3 goes into the top, 3 goes once, 3 goes into the bottom twice, and now I can multiply what's left on the top and the bottom. On the top, I had just an x minus 2. On the bottom, I had 2 times x minus 1. You can leave your answer like this in factored form. That's as simplified as it can go. I like this form best because I can look at this expression right here and I notice that I can see that there's nothing that I'm allowed to cancel or cross out with here. Again, no playing with the 2's even because this 2 on top is next to a subtraction, so it's got to be that whole x minus 2 or nothing. So this is a great final answer, and when you check your answers with solutions in the homework, this is the form that I've left those answers in. Another acceptable solution would be to distribute out and get rid of any of the parentheses, so 2x minus 2. This is another way that you could write that answer, but I really like this way better because you can see if there's anything that's been canceled out, and it's less work to boot. So kind of a bonus there. For the next problem, again, we want to do the same thing. Completely simplify everything first before you try to see if there's any expressions that can be divided out or canceled from the top and the bottom when I go. So for this first example here, on the top, I have 3x minus 6. I can pull a 3 out of that and leaves me with x minus 2 behind. On the bottom, I have an x plus 5. Again, you want to kind of think of that as an entire grouping there. I'm not going to be able to cancel anything unless I cancel the whole x plus 5 group. On the other side here, I have a 5 times x plus 5. I notice there's a common factor of 5 I can pull out there, and that'll leave me with an x plus 1 behind. When you distribute that out, that gets me that 5x plus 5. On the bottom, I have a trinomial that I need to do some factoring with. So again, take some time. If you like to do those over to the side, you can kind of do that. In this case, what I'm looking for is two things that multiply to get me x squared minus x minus 2. For the first part, I have an x times x will get me x squared. For the end, a minus 2 and a plus 1. And if you double check this, you'll find that that will give me an x minus 2x in the middle. So I get that x squared plus x minus 2x minus 2. That gives me the minus 1x in the middle. And I have x squared minus x minus 2, which is what I needed. So over here, when I'm writing my factored form, I've gone ahead and figured out that it's going to be x minus 2 times x plus 1. So this is going to be my most simplified form, completely in factored form. Well, it's not my most simplified. I want to see if there's anything I can divide out. And it should be obvious now that everything is in its factored positions. In this case, notice I have an x minus 2 on the top here and an x minus 2 on the bottom here. Those are both factors, so we can divide the top and the bottom by that x minus 2, and they're going to be gone from the picture. I also have an x plus 1 here and an x plus 1 here. As long as one's on the top and one's on the bottom, they're fair game to cancel, even if they're in the same original fraction. And that's fine. So those are gone. Here I have an x plus 5. Don't try to cancel anything here because I had to have to cross that whole x plus 5 out, and there are no x plus 5s left on the numerator. So all I want to do is multiply whatever's left on the top and whatever's left on the bottom to get my final answer. In this case, I had a 3 and a 5 left on top, which I can multiply to get 15. On the bottom, everything canceled out except for the x plus 5, so that's all that remains. And that will be my final solution. So again, basically all that we're doing in this problem with multiplication is we just have more simplifying than we had in the simplifying rational expressions part of the problem. All right, continuing on down here. Here I have x squared minus 9 over 2x plus 1 divided by x minus 3 over 6x plus 3. Before I start, notice I have a division problem. I don't like that. So take the time to go ahead and rewrite that problem. Change those divisions to multiplications. So I have this. And then the last thing that I want to do here is to go ahead then, before I try to do any canceling, make sure everything is completely simplified. So let's see what happens. On the top, I had an x squared minus 9. Taking that over to the side, I'll find that x times x will give me the x squared. And if I have a plus 3 and a minus 3, that will give me the negative 9, and it'll give me a 0x in the middle. On the bottom, 2x plus 1, there's no squared, so I don't have to worry about 2 parentheses factoring there. And there's also no greatest common factor, so I'm just going to have to leave that as 2x plus 1, that whole group. Over on the other side, I'm going to work on this 6x plus 3. No squared, so I don't have to do the 2 parentheses factoring, but there is a common factor of 3 that I can pull out, and if I pull that 3 out, what I'm going to be left behind with is 2x plus 1. Again, double check that out. 3 times 2x gives me 6x, plus 3 times 1 gives me plus 3, which is what I needed. On the bottom, there's no squared, there's no common factor, so I just leave the x minus 3 on the bottom. All right, so almost done with this set of expressions. I want to see, are there any common factors that I can divide out? I have an x minus 3 on the top here and an x minus 3 on the bottom here. That whole group can go. Here I have a 2x plus 1 on the bottom and a 2x plus 1 on the top, and those can go. So that was pretty great. A lot of things canceled out. I was still left with a 3 and a x plus 3. Those are both on the top. You can write that as 3 times x plus 3 over 1. You could write that as 3 times x plus 3, or you could multiply it out and write that as 3x plus 9. Any of these 3 forms of this solution would be okay. In 13, again, it's another division problem. Remember, we always want to take our division problems and rewrite them as multiplication problems before we start. So here I'm going to have x cubed plus x squared minus 6x divided by 3x minus 3. Change the divide to times, and then I need to flip the other fraction over. So I'm going to have x minus 1 over x minus 2 there. Now I'm going to need to completely factor each of these expressions. That very first one on the top there has a lot involved. Let's take a second and do that. X cubed plus x squared minus 6x. Notice there's a greatest common factor of x in all of those, which is good because I don't like that cubed factor there. So if I take out an x, I'm left with x squared plus x minus 6. Then I can try to factor that into 2 parentheses since there's still an x squared there. X times x will get me the x squared. To get the minus 6, I can try a 2 and a 3. One needs to be a plus and one needs to be a minus. And if you check this, the plus 3 and the minus 2 is the combination that we'll need to get a plus 3x minus 2x gets me a plus 1x in the middle there. So I want to rewrite that whole top expression there. X cubed minus 6x, or x cubed plus x squared minus 6x is now going to become x times x plus 3 times x minus 2 on the top. On the bottom, I have 3x minus 3. No squared terms, so I don't have to do any of that 2 parentheses factoring, but there is a greatest common factor of 3 I can pull out, which will leave me as 3 times x minus 1. On the other side, remember it was times, there was an x minus 1. No greatest common factor, no squared. On the bottom, we're going to have x minus 2. Again, no squared terms or greatest common factors to worry about. At this point, I have factored everything as completely as possible, so I want to see if there are any common factors in the numerators and denominators that we could reduce or cancel out. There's actually quite a few. In this particular case, the x minus 1 on bottom will cancel with the x minus 1 on top. X minus 2 on the bottom will cancel with the x minus 2 on the top. And what I'm going to be left with is an x and an x plus 3 in the numerator, all divided by 3 in the denominator. This is my final answer. Don't try to cancel that 3 out because I can't cancel that 3 unless I do the whole x plus 3 expression. If it's next to a plus or minus, never ever do it. All right, the last kind of example that we're going to look at that might look a little bit strange sometimes is something like problem 14. Notice in this one, it looks really crazy. It's like fractions inside of fractions. But remember, a fraction bar really means division. So if I see that big fraction bar in the middle, something that really helps me is to take a second and rewrite that as a division. So what this is the same as is 4a minus 8 over 15 divided by 6 minus 3a over 20. Okay, well that seems a lot more manageable and a lot less scary looking. When I look at this, I remember that if it's a division problem, I need to flip my fraction over So change it to a multiplication and use the reciprocal there. Okay, so this is my new version of my expression. At this point, I need to factor each of my values before I try to do any canceling or reducing, because I want to see, are there common factors, in fact, that I can do anything with. On the top, I notice there's a greatest common factor of 4. If I pull that out, I'm left with a minus 2. 15 on the bottom, we can't do anything with that. Over on the other side, I have a 20 on the top. And on the bottom, I've got to factor out that 6 minus 3a. A couple of things I want to make sure that you notice. First of all, is that the a terms are not at the beginning. So do turn those around. And now I notice that there's a negative, and I don't like the negative in front of it. You want to make sure to get those leading terms to be positive and to make sure your terms are in order from biggest to smallest before you're done, so that you can make sure to recognize any common factors that are possible and use them to reduce out. In this case, notice that 3 also goes into both of those, so I can pull a negative 3 out. Negative 3 times a will get me negative 3a, and a negative 3 times minus 2 will get me a positive 6 there. So what I have here is negative 3 times a minus 2. And now everything is completely factored in this expression. So now I just need to see, can I cancel or reduce of anything? And then when I'm done, multiply across the top, multiply across the bottom. There are some common factors I can divide out. There's an a minus 2 on top and bottom that can divide out. There's the 15 here. 5 will go into both the top and the bottom. 5 goes into 15 3 times, and 5 goes into 24 times. And that's really all that I can do. Notice I do have a pair of 4s, but they're both on top, so you are not allowed to cancel those. So multiplying across top and bottom, I end up with a 16 on the top. Multiplying across the bottom, I get negative 9. You can write your answer as this. A lot of times you'll see the negative written out in front. And that's fine. Your negative values can either be written at the top of the fraction, the bottom of the fraction, or pulled out in front of the fraction, and those will all mean the same thing when you're done.